Hello everybody, this is an extra video about how to use K-maps, some examples of K-maps, kernel maps being used to simplification, Boolean equation simplifications. So you can see here that I have, it's an equation from the other video that I have. And what I'm gonna do is I'm gonna build the K-map for this equation and see how can we simplify this. So it's three variables, A, B, and C. So we can write like A, B, and C. I always use like the most significant bit, let's say, from the left to the right. So we need here to we're gonna need two lines, 0 and 1 for A, and we're gonna need 4 columns for B and C. So here is column 0 and 1. B, it's, as we saw in the lecture, B for this column, B is 0 and C is 0. B is 1 and C is 1. B is 1, C 1, B1, C 0. So what we're gonna do now is see those mean terms here, those terms, and see where they can fit here. So for example, this first one is complement of A, so 0, 0, and 0. So 0, 0, and 0 is this term here, is this implicant. And this guy here, so it's A, complement of B, complement of C, so it's this line, A, complement of B, complement of C is this first one here. So when we have this this term, it's true, and when we have this term, is true, and when we have this term here, A, complement of B and C, so you can see that from the line is here, this one is true as well. And all the other situations, our function is false. So you can see that we have these three terms, and we can group them together to have our simplified version. So if I group these two members together here, we can see that in this group here now, only the variable A changes in both of them. So we can eliminate the variable A for this implicant here that we group together. So, and the implicant is used, it's complement of B and complement of C. Or we can also group these two implicants here. So we have A, and we can see that C, that's the second term here, so it's 0 here and 1 here, so C changes here. So we have this implicant, it's gonna be complement of B and A. Can you see? So A doesn't change, B doesn't change also, B is 0 here and 0 here, and that this is our simplified version, simplified equation. I have another example, and that's y it's equal to, I'm just gonna copy here really fast, A, B, complement of C, complement of D, or A, complement of B, complement of C, complement of D, or A, B, complement of C, no, sorry, complement of D, or A, complement of B, C, complement of D. Okay, so in this case we have 4 variables, so it's going to be a 4 by 4 K-map. So we have A, B, again, so I start from the left to the right, so A, B, C, and D, and we're gonna use 4 lines, so it's 0 and 0, 0 and 1, 1 and 1, 1 and 0. So every time I'm just only changing one variable at a time, so 0, 0, 0 and 1, 1 and 1, so I only change this one here, and 1 and 0, so I'm changing this one to 0. And I'm gonna need 4 columns, right? So yeah, again, so 0, 0, 0, 1, 1, 1, 1, 0. And we're gonna write this, I'm gonna just like darkens this one. So we're just gonna write this equation here with the correct terms and see how this can be simplified. So AB, it's gonna be this line, complement of C and complement of D, so it's 0 0 is this guy here. So A and complement of B, so it's this line here, A is 1 and B is 0. Complement of D, C and complement of D, so it's 0 0 is this guy here. So A and B again, so it's this line here, but now it's C. Remember that's not complement of C, it's C and complement of D, so is this space here. And now we have A and complement of B, that's the last line here, C and complement of D, so C and complement of D again, so it's the same. Yeah, it's the same tool here. So all the other mean terms or all the other possible are 0. And so you can see that we can have these mean terms here, so that will be so you can see that B changes, so we have A and C and D for this term is the same, so complement of C and complement of D. Or we can also have again these two terms here, and on these two terms we're gonna have A again, also B changes, and we're gonna have C and complement of D. But because of the nature of cardinal maps, we also have a better simplification. This one is already correct, but it's not the minimized version. So we also, because this, you can see that this column here, it's only one change of variables from this. So this one is 0 0 and this one is 1 0. So you actually can go around and group these 4 implicants together. And in this case that we have this 4, we can see that the only ones that are not changing here, it's A. So A, it's the same here and the same here. And the other one that's not changed, so you can see that C changes, but D doesn't change, so in complement of D. Is that correct? There's one mistake here actually. Sorry. So yeah, this is the minimized version, because you can group this in this way, and actually you can group, like if you have implicants, true implicants here, we can group the corners as well. So you can go around this way on the horizontal, on the vertical lines, and this way on the rows as well. Another thing that I want to point out on these kernel maps for 4 variables is that you can see that this is A and this one is complement of A. Here is D, here it's B, and here it's sorry, here here is C. It's not here. Can you see that we have these regions where this is true, this is A, this is B, and here is complement of A, and here is B, and here is complement of B. So we have these regions that you can see. Sometimes it's easier to see in this way. So this is D, and this is complement of D. This is C, and these 2 columns are complement of C. This is something that you can see. You can see. I have a bigger one now. I think we still have a little of time. I don't want this video to be like really long, but so we have. I'm just trying to copy one equation here that's pretty long. So we have A complement of B. I'm just gonna copy here really fast, where you guys can see. A of D, A, B, C, and D, or A, B, C, and D. And we have others: complement of A, complement of B, complement of C, complement of D, complement of A, complement of B, complement of C and D, or complement of A, complement of B, complement of C and D, complement of A, complement of B, C and D. So let me check. So C, D. Oh, so this one is wrong. This one is not here. This one is right here. So this is a big one. We're just gonna build this the 4 variable truth kernel map. Here's gonna be AB, CD. It's the same that I did before. So 4 lines, 4 columns. 0 0 0 1 1 1 1 0 0 0 0 1 1 1 1 0. Basic kernel map for 4 variables. And now we're gonna fill this equation here. So you can see that all these guys here are A and complement of B, right? So it's in this line here. All of them, so A, B. So we have complement of C is 0 and 0. So it's 1 0 0 0 1 0 0 0. This one is 1 0 0 1 1 0 0 1. This guy here. 1 0 1 1 1 0 1 1 1 0 1 0 1 0 1 0. So it's here. And this one is 0 0 0 0. So it's here. 0 0 0 1 0 0 0 1 0 0. This one is supposed to be 1 and 0 0 0 1 and 0. And 0 0 1 1. So 0 0 1 1. So again, this one, like, it's pretty big, but we have so many repetitions that actually you can group all this 4 with all this 4. And the simplified version of this, you can see that here we have one A is 1 and here A is 0. So A is out. B is 0, B is 0, so complement of B it's in. You see that in all those lines here, you have 0, C is 0 here, C is 1 here, D is 0 here, D is 1 here, so C and D is out, and your minimized version of the equation is just complement of B. Because all the other here's are, I forgot to put, but those are not implicants. And that's it. So I think it's a good idea to practice the simplifications, and we're gonna see some of this in the labs as well. Thank you. See you soon.